In this video, we're going to discuss the difference between net area and total area as it pertains to definite integrals. Before we begin, it's important to realize that if a function f of x is negative on some interval from a to b, so perhaps the function looks something like this, then the region that the integral from a to b of f of x dx actually describes the area in between the curve and the x-axis. And so for this reason, this area is going to also be negative. In other words, the integral from a to b of f of x dx must be negative. So thus the net area refers to what you get when you combine the positive area with the negative area. For example, consider the integral from 0 to 4 of negative 1/3 x plus 1 dx. We have a positive area, that is the area that occurs above the x-axis from 0 to 3. This can be represented by the following integral from 0 to 3 of negative 1/3 x plus 1 dx. However, the region from 3 to 4 is underneath the x-axis and is represented by this area. That integral is represented by the integral from 3 to 4 of negative 1/3 x plus 1 dx. It turns out, using a property of integrals, that these two integrals add up to simply make the integral from 0 to 4 of negative 1/3 x plus 1 dx. So therefore, just taking the integral in and of itself will give you the net area. Total area refers to the area bounded by the curve in the x-axis and is always thought of as a positive. Taking the same example as before, we would still have the area above the x-axis and below the x-axis, and so we would simply treat the area below as a positive. Treating it as a positive means we can think of this as that part of the graph reflected about the x-axis so that it is now above the x-axis, and so the entirety of the area lies below the curve. The way that we do this is by making the integral absolute value. In conclusion, the difference between net area and total area is as follows. Net area is simply the integral itself, which is the combination of a positive quantity that represents the area below the curve when the curve is positive or above the x-axis, and a negative quantity that occurs when the graph is below the x-axis. Total area, the area is always thought of as a positive. So the parts that are below the x-axis are reflected about the x-axis and thought of as positive area, which algebraically has the same effect as making the function absolute value. To put numbers on these two explanations, the bottom expression represents the net area and would just simply result in a net area of 7/6. The total area would be a similar strategy, but instead of subtracting the negative part from the positive, you would simply be adding them. So 3/2, that represents the green area here, would then be added to 1/3, which represents the area of the blue, and so the total area would be 11/6. So you want to pay attention to what they're asking for in the problem. If they ask for total area, you'll need to think of it as an absolute value of whatever the given function is and act accordingly. If it's the net area, you simply need to calculate the definite integral.